Okay, greetings and welcome to the lecture on engineering mechanics. So we are almost okay. We have finished almost unit number 3, part A. Right now we will move on to unit number 3, part B, and these are the contents of part B. Forces in space. Please note that it is a space force. Resultant of concurrent and parallel forces in space, equilibrium of concurrent and parallel forces in a space. Okay, so space force system. So first of all, what do you mean by uh, a space force, say in short? Okay, a force is said to be a space force when its line of action is not lying in any of the plane, that is neither in plane xy nor in the plane xz nor in the plane yz. Okay, so we know that fine. Okay, if I construct, say this is as a three-dimensional space with x coordinate, y coordinate, and say suppose this as a z coordinate, right? So this is your xy plane, correct? Right, say what I can say suppose vertical plane, right? And this is horizontal plane. Xz plane is a horizontal plane, right? And there is another plane, so this is yz plane. Okay, so if any of the force is lying in any of the planes, say suppose a force F is lying in say xy plane, it is called as fine a two-dimensional case, which we have studied in unit number 1 as well as in unit number 2. Okay, or till date whatever we have studied, it was for two-dimensional case. Two-dimensional case means what? It's a coplanar force system. Coplanar, we have studied the different systems of force systems, right? Coplanar force system, concurrent, coplanar, etc. Right now in general, what do you mean by coplanar force system? If all the forces are lying in a single plane, then that force system is called as coplanar force system. Now this coplanar concurrent, this coplanar system, force system, may be concurrent, may be non-concurrent, right? Okay, and it may be find the parallel, what we can say, right? Okay, non-concurrent means fine, we can say as a parallel force system, right? And in this is also called as a general force system, something like that. So suppose this is a body which is acted upon by some n number of forces, something like this. So we have seen something, a frame or a bar, lever arm, something like this, acted upon by one force here, other force here, somewhere force here, and so on, find something like this. So this is what the coplanar general force system. Okay, so which we have already studied this particular system, correct? Now coming back to this, okay, this particular discussion. So I hope now you have understood what is two-dimensional. Two-dimensional force system means coplanar force system. Coplanar force system. Okay. Now, okay, now this force, this F, it may be either in xy plane, or it may be say in other plane, that is maybe yz plane, or maybe in say this xz plane. So all this is what is called as two-dimensional or the coplanar force system. Okay, something like this. So suppose these are the n number of forces, say force F1, then this force F2, and say this is force F3. All these forces F1, F2, F3, all these forces are lying in xz plane. Okay, so this is nothing but what? A two-dimensional or a coplanar force system. Similarly, there can be n number of forces lying in say in this thing, xy plane. This is also a 2D case, two-dimensional case or coplanar force system. Okay, now what do you mean by a space force? So space force means what? The force, a force is not lying in any of the plane. Say suppose fine, okay, and this is x-axis, this is y-axis, and say suppose this is your z-axis. Okay, and a space force is something like this, see now, something like this. Now this particular force, now imagine this is a three-dimensional case, please note that. So this force is not lying in any of the plane. It is not lying neither in xy plane, nor in xz plane, nor in say this yz plane. And that is why now this force will have three components, one along x-axis, second along y-axis, as well as along z-axis. As far as 2D case is concerned, say 2D case in xy plane is concerned, say suppose this is the force F. We have studied how to resolve a force F, which is lying in say one plane, say xy plane. Okay, in this case, what we did? Okay, here better I have drawn this figure here, right? So this is a revision, fine, revision slide. See now in this revision slide, for two-dimensional case, say in xy plane, the force F, which is lying in xy plane. So this is the force F, which is lying in say this xy plane, x-axis and y-axis. Now this F is lying in xy plane. Please note that. And now here, this force is making say angle theta x with respect to positive x-axis. So please note that we are measuring the angle theta x as the angle made by this F with respect to positive x-axis. So please note that how we are defining the value of theta x. And the same knowledge I am going to extend for a three-dimensional case, that means for a space force. Okay. Similarly, let this theta y is the angle made by this F with respect to positive y-axis. Please note that positive y-axis. All these angles we are measuring with respect to positive axis, positive x-axis, positive y-axis, etc. Right. Now, if I want to know the x component of this force F, of course, now it will be no doubt this fx will be F into cos of theta x. Please note that. Now here in this particular example, of course, here theta x is no doubt it is greater than 90 degree, correct? Okay, but less than 180 degree. So the value of theta x is lying in between 90 to 180 degree in this range, this range 90 to 180 degree. And what about all the values? The values of cos of the angle which is in between 90 to 180. Of course, it is negative. Okay, and that is why ultimately, say suppose for example, theta x is suppose 110 degree, which is greater than 90 degree, and this F is suppose 10 Newton, for example. Then what should be this Fx in this case? Fx will be equal to this 10 into cos of 110. Okay, so if you take if you do the calculations on calculator, you will get negative sign. Please note that you will get negative sign to this particular product. Okay, because cos of any value which is greater than 90 to 180 is minus. Okay, so cos of 0 is 1. Cos of 90 is, yes, what is the value of cos of 90?
0.
Correct. In cos of 180?
Minus 1.
Yes, correct. Okay, that means what? Okay, you can check it on your calculator. Even you have studied at 12th standard, right? Okay, so in short, now see now what is the direction of Fx I have shown? It is in negative x direction, right? So this is our positive x direction, right word. Vertical upward is positive y direction, right? So now, please, I hope you are getting what I'm saying. So here theta x is measured, or theta x is the angle made by F, angle made by this force F with respect to positive x-axis. Okay, and the value of theta is lying in between 0 to 180 degree. Please note that. Okay, the value of theta is never be greater than 180 degree. I mean, in between what you can say 270 or say 180 to 360. No, we are always expressing the value of all the values of theta. That means angle made by that F either with respect to positive x-axis or positive y-axis in this particular range 0 to 180 degree. Right. Similarly, now see here. Angle made by this F with respect to positive y-axis, it is theta y. And in this case, it is clear that theta y is less than 90 degree. So of course in this case, say suppose theta y is equal to, say for example, say 30 degree. Okay, so what should be this thing, I mean the y component. So this is what the y component I have shown here, this much, correct. So this Fy is given by this expression, correct. Y component of this force F is F into cos of theta y, F into cos of theta y, right. So here in this example I have shown theta less than 90 degree, and all the cos of all the angles less than 90 degree, I mean 0 to 90 is always positive, correct. And that is why here you will find that the y component of this particular force is in positive y direction, this much. Okay, I hope you are getting what I am saying here, right. So in short, now as I already mentioned while discussing the resolution of a force in case of a two-dimensional case. So finding, see here we are finding a rectangular component. That one more point let me mention. All these are what? Rectangular components. Okay, these are the rectangular. So this Fx, this Fy, these are the called as the rectangular components of this force F. Okay, rectangular components means what? Angle between those components is 90 degree. That means angle between this Fx, Fy is 90 degree. They are mutually perpendicular to each other. Okay, so here when we are finding rectangular components of a force, simply what we are taking? We are taking projection of that force onto the respective axis. That means what? If I want to know the x component of this force F, simply what you do? You take its projection onto x-axis. So this is the x-axis, correct? So from this, taking the projection means what? Now from this end, say the force, you drop a perpendicular onto the line of action of that axis. So this is 90 degree. Okay, right. Now this length is nothing but what? The magnitude of what we can say, or the projected length of F along x-axis, and this projected length is nothing but what? The say x component. Okay, similarly, if I want to take the component, if I want to find the y component of this F, simply you take its projection onto the y-axis. So projected length is this much. Okay, this much. This is what? The projected length. Only this length. Okay, so this projected length is nothing but what? The y component of this force F. Okay, I hope you have understood. The same knowledge I am going to extend to resolve a space force along x-axis, y-axis, and z-axis. Right. Now see. So in short, what you have to remember? The rectangular component of a force along any axis, it means that its projected length. And projected length means what? Its cos component. Please note that. Projected length means what? The cos component. Again, I'm repeating. Projected length means cos component. Just like here, while finding the x component of force, we have taken F into cos of theta x. While finding the y component of the force, we have taken F into cos of theta y, cos component. So projected length means cos component. Please note that. And how we are defining that theta? Theta we are defining as the angle made by that F, either with respect to positive x-axis or positive y-axis. So here theta x we are defining as angle made by F with respect to positive x-axis. I have already written here. Similarly, what is theta y? Angle made by F with respect to positive y-axis. That's very important, right? And in vector notation, we are representing. Okay, please note that here dark, I mean the bold faced letter means it's a vector quantity. Okay, this is what the symbol I have used. Okay, and not bold means this is the scalar quantity, right? So F, this vector F, this force vector F, that I'm writing in vector form as Fxi plus Fyj. Now what are these I and J? Yes, can anybody answer? What are these I and J? These are the correct, very good. These are the unit vectors along x-axis. So this is I is a unit vector along x-axis, and this is the j is a unit vector along y-axis. Okay, while this is a vector, f is a vector. While what about this fx? Fx is x component of this force f, force vector f. What is y? Y component of this force. And of course, this fx and fy both are scalar quantities. Please note that fx and fy, because these are only magnitude. And when you multiply this fx by this unit vector I, the whole quantity becomes a vector quantity. Please note that. So scalar multiplied by vector is ultimately a vector quantity. Similarly for this fy into j. So ultimately fy multiplied by j is a vector quantity, while only fy is a scalar component. Okay, I hope you have understood. So the same knowledge we are going to extend for the resolution of a space force into its rectangular components. Okay, so let us consider this particular figure. Okay, so this is the origin. Okay, this is positive x-axis, positive y-axis, and this is positive z-axis. And this is your space force. Now here you can imagine. Here you can imagine. So this is O to A is the force F. Right? Now see here. Now this force F is given. And then after knowing this force F, then we have constructed a cube as shown in this figure. We have constructed this cube A, B, C, D, E, etc. Okay, so please note that. Now while constructing this cube, or I mean we have constructed this cube in such a way that this force F is the diagonal of the cube. OA or F, this force F becomes the diagonal of this particular cube, or it's a cuboid. Okay, I hope you have understood now. See here, right? Now see here, I am showing now. Let this theta x is the angle made by this F with respect to positive x-axis. Now theta x is measured in which plane? The plane formed by this F and positive x-axis. See here, this is that plane. Please note that this is not a vertical plane. I mean, neither it is a vertical plane nor horizontal plane. It is an inclined plane. And what is that plane? That plane is OAD. So this is that particular plane, which is inclined one. Just please imagine. Okay, I hope you are getting what I'm saying, right? So here theta x is measured, or theta x is the angle made by F with respect to positive x-axis. And of course, that theta x is measured in which plane? The plane formed by F and that axis, and that respective axis, right? Okay, fine. And hence now what should be the x component? The same knowledge I'm extending, say here. How we define theta x? Theta x is the angle made by F with respect to x-axis, positive x-axis. And then this is how we define the x component of the force. Fx as F into cos of theta x. In the similar way, I am defining this F, I mean x component of this F. Fx is equal to F into cos of theta x, where what is theta x? Theta x is, I have defined here, angle made by F with respect to positive x-axis, which is measured in the plane formed by F and x-axis, of course positive x-axis. Okay, I hope you have understood this particular concept. Now, okay, the same force F, okay, of course it is a space force which is not lying in any of the plane, right? And then we have constructed this cube A, B, C, D, E, etc. Now here I'm showing this theta y. What is now this theta y? Theta y is the angle made by this F, space force F, with respect to positive y-axis. Please note that. So theta y is measured in which plane? The plane formed by this F and positive y-axis. Okay. So of course means what is that plane? That plane is OAB. So this is that particular plane. So in this particular plane, OAB, in this particular plane, the angle theta y is measured. Okay, so in short, theta y is the angle made by F with respect to positive x-axis, and it is measured in the plane formed by F and positive y-axis. Very simple, right? Now, if I want to know the y component of this force F, simply I must have to take its projection onto y-axis. Simply what we did here, in order to find out the component along maybe x-axis or y-axis, what we did, simply we have taken the projected length of F along x-axis, which is Fx here. That is nothing but what? The x component. The same knowledge I am extending here. So this is the F. Now I am taking its projection. I am taking the projection, I mean projected length of this F onto y-axis. That projected length is nothing but what? The magnitude of that force. And of course, it should be this O to B. O to B is the projected length, right? And of course, what should be the magnitude of that O to B? It must be, this is what? Fy is equal to F into cos of theta y. Okay, so this is Fy. O to B is Fy. Fy is F into cos of theta y. Right? I hope you are getting what I'm saying. I'm extending whatever I discussed for 2D case to this 3-dimensional case. Okay. So similarly, now I want to know the Z component. Okay, the same force F. Right. After knowing this force F, I have constructed then this cube. Right, considering that force F as diagonal. Right. Now here I am defining theta z. Theta z is the angle made by this F with respect to positive z axis. Angle made by F with respect to positive z axis, and it is measured in the plane formed by this force F and the positive y axis. Okay, that means what is that plane? That plane is OAE. So this is what is that plane, this particular plane, right? I hope you are getting what I'm saying. Now, what should be the z component of this force F? Simply you take the projection of F onto z axis. So what should be the projected length? This projected length is Fz is equal to F into cos of theta z. Right? So depending upon the value of maybe find say theta x, theta y, theta z, if it is, if say for example, if I consider the example of say theta x, if the angle of theta x is in between 0 to 90, then that particular component will have, yes, positive sign or negative sign. If any angle, maybe theta x, theta y or theta z is lying in this range 0 to 90 degree, what should be the sign of that particular I mean component? Positive, negative? Yes, very good, positive. And when the theta x is in between 90 to 180 degree, 90 to 180 degree, then what should be the sign?
Negative.
Correct, negative sign. Negative sign means it will be acting in negative direction, maybe negative x direction, or maybe negative y direction, or maybe in negative z direction. Understood what I said? Any doubt till this discussion? Yes?
No, sir.
Fine. Okay. Yeah. Now one more thing, as I already mentioned, that we are expressing the values of theta x, theta y, theta z in the range 0 to 180 degree. 0 to 180 degree. Okay. Say for example, now the force is something like this. Okay. For say 2-dimensional case, this is the force say F1. Now how you are going to define here theta x and theta y? Okay, so here, okay, these are 2-dimensional case, please note that, and the same knowledge we are going to extend for 3-dimensional case. So for 2-dimensional case, this is the F1, which is lying in say this xy plane, but the force is something like this. Now how you are going to measure theta x? So this is what the value of theta x. I will say this as say theta x1. Okay, Again, in this case, theta x1 is of course greater than 90 degree. So what should be the x component? X component, simply you take the projection of this f1. So this is what your projected length of this f1. So this is what the x component of the f1. I'm terming this as a fx1. Okay, I hope you have understood. Now how to define theta y? It is always measured from positive x-axis, y-axis. See, always theta, please note that theta is always measured from positive axis. Okay, so this is what your theta y. Let me use some other, yeah. So this is what your, this thing, this is theta y. Okay, as I told you, the value of theta we are expressing always in this range, 0 to 180 degree, 0 to 180 degree, right? And hence, if I take the projection of this f1 onto y-axis, of course, it will be on the negative side. So this will be your projected length, correct? So this is the projected length, which is nothing but what? Fy1. And of course, what should be that? Its magnitude will be f1 into, yes, can anybody answer? What should be magnitude of fy1? f1 into
Cos
yes,
theta x1.
No, cos theta x.
Sin theta. Sin theta x1.
Now, please note that you never express the component in terms of sine. That's what I told you. Please note that. Whether I mentioned sine here anytime?
Cos theta
Never.
y1.
Please note that here. Listen first. When we are finding the rectangular component of a force, rectangular component means what? Its projected length. That's all. And projected length means what? Its cos component. Cos component. Please note that. Okay. So I am not defining any of the component in terms of sine. Okay. Fine, it's well. It is true only in case of two-dimensional case. But as far as three-dimensional case is concerned, the sine component is not at all applicable. Not at all applicable. Okay. Okay. So just you remember, again I am repeating, this is a very important statement. Finding the rectangular component means finding its projected length onto the respective axis, and projected length means the cos component. Okay, so please remember these two statements, which are very, very important. So if theta y1 is the angle made by f1 with respect to positive y-axis, this is what I have shown. So what should be the y component of this force, which I have shown, which is fy1, and hence what should be fy1? Yes, now please answer.
Minus f1 cos theta.
No, don't give again minus sign. Don't give minus sign. That whether it is plus or minus, that will be taken into account by the value of theta. The value of theta. Samajhte? Getting what I'm saying?
Yes, sir.
Okay. Now please note that. Yeah. So simply, yeah. What should be fy1?
It theta y1.
f1 cos theta y1.
Correct. f1 into cos of theta y1. Very good. f1 into cos of theta y1. So for example, say suppose f1 is say 10 Newton. Okay. And say theta y1 is, of course, as from this figure it is clear that theta y1 must be greater than 90 degree. Correct. Say suppose it is say 125 degree, for example. So using the calculator, you can check it now. Fy1 is equal to f1 is 10, magnitude is 10, into cos of 125 degree. Just you check on the calculator and let me know its value. Yes, anybody is having calculator, please do it fast and tell me. Of course, you will get it minus. Yes, minus how much? Okay, something that's so much.
Minus 5.73.
Okay, minus 5.73 Newton. Correct. Minus, please note that minus. So this theta, I mean the value of theta will give the sign, whether it is positive component or negative component. Okay, is it clear?
Yes, sir.
Yes, sir.
Now everyone please mute yourself. I don't want any disturbance. I don't want any background sound. Please mute yourself. Okay, fine. The same. Okay, now one more. Yeah, let us move further. Let us move further. So similar to this two-dimensional case, the force vector I'm representing in vector form as F is equal to Fxi plus Fyj. In the similar fashion, I'm expressing this in three-dimensional case. I'm expressing this result. I mean the force vector F as Fxi plus Fyj plus Fzk, where I, J, K, these are the unit vectors along x-axis, y-axis, and z-axis, while Fx, Fy, and Fz, these are the scalar components along x-axis, y-axis, and z-axis respectively. Then similar to three-dimensional case, how will you find how will you find out the magnitude of F? Hello. This. Hey, who is she? Khushi Chavan. Khushi Chavan. Okay. Right. So coming back to the discussion, right? Okay. So similar to this two-dimensional case, I'm expressing this resultant force vector as, I mean, say, okay, that any force as a force vector as Fxi plus Fyj plus Fzk, where I, J, K, these are the unit vectors along x-axis, y-axis, and z-axis. And hence, what about the magnitude? If I know the components along x-axis, y-axis, and z-axis, I can find out the magnitude of that force vector using this particular formula. Okay, so please remember this. F is equal to root of Fx square plus Fy square plus Fz square. Now what about here? In this case, it will be only two components, that is root of Fx square plus Fy square. Correct? Already we know this concept. Correct? Fine. So similar to the two-dimensional case, the same knowledge we have extended for 3D case. Right, now in vector form, now here I know what is Fx. Fx is f into cos of theta x. I know what is Fy, f into cos of theta y. I know what is Fz. So here substituting these values of Fx, Fy, and Fz in this vector equation, I can get this very simple equation. Okay, so f is a vector. Please note that this is vector is equal to f cos of theta x I. Of course, now this is a scalar component, which is Fx, correct? While this is Fy, correct? And this is your Fz, right? Okay. Now F is the magnitude of this resultant force vector F, the force vector F. Okay. And taking this magnitude as common, I can express the force vector F as F, where this F is the scalar component of this F, into bracket cos of theta xi plus cos of theta yj plus cos of theta zk, right? Now I am expressing the above expression as F is equal to the magnitude F into this lambda, where lambda I am defining as a unit vector. Okay, the unit vector, of course, now how to define unit vector? The unit vector is equal to the vector quantity divided by its magnitude. Correct. This is what in general we can define. Sorry, this is what in general we can define the unit vector. So unit vector is equal to any vector quantity divided by its magnitude, right? So this is how we are defining the unit vector, the force vector divided by its magnitude, right? So of course now So this is a vector, while this is a scalar. This f is the scalar quantity, right? So of course the magnitude, the magnitude of this unit vector must be 1 unity. And what about the direction of this unit vector? The direction of this unit vector, it must be same as that of the given vector, okay, which I have shown here, right? So this is that your vector is force vector, which is equal to f into lambda, right? So this is the force vector given. This is your force vector, right? And after constructing the cube, you will get this corresponding, what I can say, the x component fx, this as a y component, and this as a z component of this force. Okay, now this is the unit vector I am showing here, whose magnitude is 1. This is the unit vector, only this particular length. And when I resolve this unit vector along x-axis, the corresponding magnitudes along x-axis, y-axis, and z-axis have been shown by this particular cube. Okay, I hope you are getting what I am saying, right? So of course here, now here, so what I will do now, okay, I am defining now this unit vector as lambda is equal to f divided by, this vector quantity divided by its magnitude. Okay, so if I divide it, definitely I will get this as a form, very simple, correct? So it means if I divide this expression by its magnitude, then this f gets cancelled, and hence you will get only this quantity, right, which is written here. So expression for the unit vector is cos of theta xi plus cos of theta yj plus cos of theta zk, and of course the direction of this unit vector is same as that of the given force vector f, right? So similar to the force vector, I'm writing this the unit vector lambda bar as, say, lambda xi plus lambda yj, okay, plus lambda zk, sorry, lambda zk. Okay. Now what about this lambda x, lambda y, and lambda z? These are nothing but what? The x component, y component, and z component of this unit vector. And of course, those must be what? So this is nothing but what? Your lambda x, while this is lambda y, and of course this is lambda z. So these are what the expressions for lambda x, lambda y, and lambda z. Now what about magnitude of this unit vector? Of course, we know that its magnitude is 1. Now what is the formula for magnitude? It must be find square root of cos of theta x square plus cos of theta y square plus cos of theta z square. Right, now taking square root on both sides, I will get this as a very important identity. Very important. Please remember this for equation. Very important identity. So 1 is equal to cos of theta x square plus cos of theta y square plus cos of theta z square. Okay. Now this cos of theta x, cos of theta y, cos of theta z, these are known as direction cosines of the force F. So please note that I have not defined any of the component in terms of sign. Okay, right now, and why we have not defined, I think you have understood it, because we are finding rectangular component of the force, and finding the rectangular component of the force means what? Taking its projection onto the respective axis, and projected length means what? The cos component. Okay, so this cos of theta x, cos of theta y, cos of theta z, these are known as the direction cosines, right? Okay, now let's move on to one problem. Let us solve one problem and then we will stop. A force acts at the origin of a coordinate system in a direction defined by the angles theta x 43.2 degree. Please note that now theta x is 42.3 degree. That means the x component must be positive. X component must be positive means what? It must be in positive x direction, because it is less than 90 degree. Theta x is less than 90 degree. Next, and theta z is equal to 83.8 degree. Again theta z is less than 90 degree. That means the z component of the given force must be in positive z direction. Okay, fine. So here theta x and theta z have been given. Okay, fine. So knowing that now, okay, there is a full stop here. Knowing that the y component of the force is minus 50 newtons. Now please note that what is given here, Fy is minus 50 newton. Minus 50 newton means what? The y component is acting. So as far as, say, suppose if as far as this particular figure is concerned, the y component is in negative y direction. Negative y direction means what? What should be the value of theta y? Can anybody answer? What is the range
greater than 90?
Correct, very good. Greater than 90 degree means in between 90 to 180 degree. That's very, very important conclusion. Okay, so here Fy is minus 50 Newton means the value of theta is lying in the range of 90 degree to 180 degree. That's very, very important conclusion. Very important conclusion. Okay, fine. Now the question is determine, first question, the angle theta y, which must be in this range. Okay, and the second question, the other components and the magnitude of the force. The other components means theta x, sorry, fx and fy, sorry, fx and fz. Okay. Yeah, how to attack now this problem? So we know that this is a very important identity which we have derived on the previous slide. So 1 is equal to cos square theta x plus cos square theta y plus cos square theta z, right? Now rearranging this as expression, because the value of theta x and theta y have been given. So cos square theta y is equal to 1 minus cos square theta x minus cos square theta z. Right, so substituting the corresponding values of theta x and theta z, right, we got cos square theta y as 0.4569. Okay, and after solving we got cos of theta y as 0.6759, and after doing, I mean, when you take the cos inverse of this value on your calculator, you will get the value of theta y as 47.47. which is less than 90 degree. But this is not our final answer. Please note that, because we know that the value of theta, the value of Fy is negative. Negative means the range for theta y is 90 to 180 degree. So after solving, we got that theta y is 47.47 degree. Okay, so here I have mentioned, but the y component of the force is negative, which is minus 50. So theta y must be, yes, what should be the value of theta y? 180 minus 47.47, this value. This we have to subtract from 180 degrees. So 132.53. Right. So you can check it for, as we know that the value of, okay, Fy is 150. Okay, we know that Fy must be equal to F into cos of theta y. Okay, while this is our final answer for theta y. Okay, now value of theta y, value of Fy is given, which is minus 50, correct? Okay, and this is what is your this thing F, okay, multiplied by okay, already I have written here. Yeah, fine, I have written here. So this is, okay, minus 50 into F into cos of 132.53. Okay, so when, please note that now we are substituting the value of theta y, which is in this range 90 to 180 degree, and that is why we have substituted the value of Fy with a negative sign, correct? So after solving, we got the value of F as, of course, now this is magnitude, which is a scalar quantity. So scalar quantity is always expressed in with, say, okay, positive sign. So after solving, we must get that this value with negative, I mean cos of 132.53 as negative. So this negative sign and this negative sign ultimately becomes positive, and hence we got the magnitude of that force F as 73.98 Newton. Okay. And then find out the other two components. So Fx already we know Fx is equal to F into cos of theta x. So already we have found out the magnitude of this force F as 73.98. Okay. And value of theta x is also given 43.2, which is less than 90 degree. And hence Fx is acting in positive x direction. Similarly, you find out Fz. Fz as F into cos of theta z. Already we know the magnitude of F 73.98 into cos of theta z. Theta z is given in the problem 83.8, which is less than 90 degree, and hence Fz is in positive z direction. Okay, so we got the values of Fx, Fy, and Fz. And if you want to check, I mean, it must be now this F is must be equal to root of Fx square plus Fy square plus Fz square. Sorry, Fz square. Okay. Now what is the magnitude F? Magnitude of F 73.98. Okay, 73.98, and this must be equal to root of Fx square, which is 53.98 square, plus what is Fy? Fy is minus 50. Yeah, of course, taking square, it will become TK plus Fz. Fz is 7.99. You can check it whether this square root of this quantity is equal to 73.99 or not. Yes, definitely you will get it. Okay, fine. So this is the right time now to stop here. So in the next class, we will discuss few more numerical problems, and also we will discuss when a force is defined by its magnitude and any 2 points on its line of action, then how to resolve the force. So this case is very, very important. Okay, so just please wait. Let me download the attendance.